One of the most common use cases for Vuforia Studio is pairing CFD visualizations with real-world models. This is a great way to create an engaging experience and give audiences a glimpse into a world that they normally never get to see. You can use ANSYS Ensight to generate data visualizations of your model. To learn more about this, check out our video series on using ANSYS, linked below. To prepare your file for import into Vuforia Studio, you'll need your CAD model, a .gltf file of your CFD simulation from ANSYS Ensight, and the 3D modeling program Blender. Once you have your .gltf file, you'll need to import it into Blender. Go to File, Import, and select the .gltf option. After it loads, make sure you save your Blender file in a new folder to back up your work. We first need to unpack the assets of this file into its constituent parts. Go to File, External Data, Unpack Resources, Write Files to Current Directory. Now export your file from Blender as a .obj. Make sure to keep everything in the same folder structure. This will create many files in the folder where your Blender file was saved. Now we need to configure our textures to our model. Open the .mtl file in a text editor and take note of the file name next to map_kd. You can open up the location of this file in a separate window to not lose track of it. Change the file path next to map_kd to colors.png. In your file browser, navigate to the originally referenced file. Rename it to colors.png and move it into the top level. Now it is in the same folder as the .obj and the .mtl files. Make sure the file name of your .obj is the same as the one listed at the top of the file. Head to Vuforia Studio. Using the plus button next to Resources, import your .mtl and textures file first. Only after those are uploaded, then you can upload your .obj file. You'll know it's worked when you select it for a model widget and you can see the correct shape and color. Now you can use this model like any other model in Vuforia Studio. Import the CAD model of the product and make sure to align the two. It's helpful to use the plane and axes handles to get the models closer together. For more exact adjustment of the models, you can enter numbers in the coordinates in the Properties pane. You can now author the rest of the AR experience as normal. Depending on the use case, using transparency to adjust the visibility of the CFD relative to the product is a good way to make sure the two elements work well with one another. Using CFD adds a dimension to your AR experience and breathes life into your products. In this example with the Hamilton steerable jet, CFD streamlines are used to show how the flow is steered by the jet. By using AR, you can convey the scale of the streamlines in 3D, which gives a better impression of the forces involved for this jet. In this Conflux heat exchanger experience, simulation data shows how the temperature decreases across the length of the device. In addition to streamlines, a 2D gradient plane can be used to convey data values. You can display visualizations with scale buildings, such as this one showing the flows across the roof of the Sydney Opera House. With Vuforia, you can use model targets to ensure your CFD visualizations match even the most complex of geometries. This is especially effective using AR, as these geometries are best experienced in 3D. You can even have animated visualizations, such as these ones showing the turbulent flow across the RMIT race car. This can be achieved by importing the animations of the simulation into Vuforia Studio. To learn more about that, check out our video linked in the description. In this video, we looked at using CFD data for our visualizations. We can follow a similar process for FEA and EMAG results. For more information, contact your local LEAP representative who will be happy to help you. Otherwise, take a look at our video playlist to learn more about using Vuforia Studio.